All right, now let's talk about OTC-1, outbound trajectory correction number 1. So at this point, we've done our translunar injection, we're on our way to the moon. And to get there, we're gonna fine tune our path, we're gonna make a couple of different burns just to make sure we're targeting the right direction. Now the first one is this OTC-1 burn, and really this is a critical test of that large orbital maneuvering system engine that's right here in the aft part of the Orion service module. That's really what's going to be doing our big pushing maneuvers, and it's critical for those flybys, the powered flybys of the moon, both the one that allows us to get to distant retrograde orbit and the one that comes home. Additionally, we have these auxiliary thrusters around the bottom. We have 8 of these that can provide some additional push to help out with this orbital maneuvering system engine. But OTC-1 is coming up. We'll likely make a number of these burns on our way out to the moon, and all that sets us up for essentially this slingshot that we see here before we get to the outbound power flyby. You can see that engine igniting here. Testing it on this burn is going to be really critical to making sure that it works there, and that's what's going to allow us to get into our nice stable orbit around the moon, where we can really test Orion out, put it through its paces. So coming up, OTC-1, the first in many burns using that European service module on this Artemis 1 mission. We got this just in time for the first mission in Artemis, Artemis 1, so let me use it now to take you through. As always, we're going to start off with a launch. In this case, 4 RS-25 engines ignite, 2 solid rocket boosters sending SLS and Orion skyward. On the way uphill, a couple of jettison events, things coming off of the rocket. One of the most visual will be these 2 solid rocket boosters coming off about 2 minutes into the flight after all of their propellant's gone. We also have 3 fairings protecting Orion on the way uphill, as well as the launch abort system that will come off. Now, after we get through all of the propellant in that giant core stage, we'll hear MECO, main engine cutoff. It will drop away, turning propulsion over to this, the interim cryogenic propulsion stage, or ICPS. It's going to make its first maneuver to raise up the lowest part of our orbit around the Earth, really put us in a nice circular path around our planet. And while we're in Earth orbit, we can check out Orion, make sure its systems are functioning as we expect before we commit to sending it to the moon. That happens here, the translunar injection, to a 20-minute firing of this ICPS upper stage. And what that's designed to do is really give Orion enough energy to get out of low Earth orbit and make its way to the moon. Shortly after that, the ICPS will separate. Its job pushing Orion is done. It has a couple of secondary payloads in here, some CubeSats that it'll deploy, ultimately sending itself on a path around the moon before it escapes and goes into orbit around the sun. Meanwhile, Orion, though, continues on its journey. It'll make some correction burns as it fine-tunes its path towards our lunar neighbor before we get into all the exciting stuff up close. We'll dip in for a 60 nautical mile flyby of the lunar surface using the engines on the European service module to push us around and into distant retrograde orbit, or DRO. That's this dotted line that you can see up here. This is really where we're going to learn about Orion while we fly around the moon, about 38,000 miles off the lunar surface. And we call it retrograde as the moon is heading in that direction. Orion will be heading in this one, opposite retrograde. Now, after we're done in that orbit, it'll be time to come home. We'll execute a maneuver to exit, do another flyby close to the lunar surface that commits us to coming home and fine-tuning our path towards the atmosphere. We'll make any correction burns on our way back as necessary before it's time to re-enter the atmosphere. Now, before that can happen, we'll have a spacecraft separation event. The service module, its job is done. It breaks away, ends up burning up in the atmosphere after carrying Orion to the moon and back. What this does is reveal the heat shield, the large structure on the base of Orion. Testing this is our #1 goal for the Artemis 1 flight, because when we come back from the moon, we're going to be moving at 25,000 miles an hour. That's 8,000 miles an hour faster than when you come home from the International Space Station. And what that's going to cause is this to heat up to about 5,000 degrees Fahrenheit. That's half the temperature if you were standing on the surface of the sun. So things will be very hot, but that heat shield does its job to protect the Orion capsule, which will be bringing our astronauts home at the end of these future missions. After we're through that fiery re-entry, parachutes deploy, Orion splashes down in the ocean. We'll have a U.S. Navy ship standing by with recovery personnel to pick Orion up out of the water and bring an end to the first flight in the Artemis program.